Alright, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera guys. Okay, welcome back to this channel. Okay, so in this lesson today, we are going to continue still with Lushathilias principle, but this time in this lesson, we are going to look at how, pressure, how pressure affects the equilibrium system. Okay, so this is what you're going to learn in this lesson. All right. Okay, changes in pressure. Okay, so first of all, to be only affects system with gaseous components. Okay, so I repeat. Okay, changes in pressure only affects equilibrium system that contains gaseous components. Okay, so it means that if let's say if we have other system that contains other phases, for example solids, liquids, or maybe aqueous. Okay, so this won't be affected by changing the pressure. So remember, changing the pressure only affect the equilibrium system with gaseous components only. Okay, so when we say pressure changes, so remember guys, okay, pressure changes can occur in three ways. Okay, so what are those three ways? So the first is, okay, by changing the concentration of gaseous components. But actually we have discussed this in the previous lesson. Okay, remember, in the previous lesson, if we change the concentration, either the reactants or the products, okay, so by changing this concentration, okay, so will affect this equilibrium position, right? And then second, adding the inert. So this we will discuss this later, in the next lesson. Okay, but in today's lesson we are going to focus on this class. Okay, changing the pressure by changing the volume of the reaction vessel. Okay, right. So let's go case by case. So let's discuss these changes in pressure by changing the volume case by case. So let's start with the first case, or simply I label it as case number one. Case number one. Okay, class. So let's say we have this system here. Okay, we have phosphorus trichloride gas and chlorine gas in equilibrium with phosphorus pentachloride gas. So these three gases, okay, were at equilibrium. And let's say, okay, if we look at this equation, class, so on the left side of this equation, there are 2 moles of gases. So we have 1 mole of PCl3 and 1 mole of chlorine gas. Okay, while on the right side of this equation, there is only 1 mole of PCl5 gas. Okay, so let's say what we do to this system. Okay, so right now the disturbance is, okay, we decrease the volume. For example, let's say the 3 of these gases were in a container, and let's say on top of this container there is a plunger or a piston on top of this. Okay, and initially the 3 gases, PCl3, okay, chlorine, and also PCl5, okay, were at equilibrium. And then what we did was, okay, we plunge this, or we push the piston down, we compress the gases. So it means that if we compress the gas, the volume shall be decreased. So volume decreasing. So right now, what happened to the system? Okay, that is what we are going to look at. What will happen to this equilibrium system when the volume is decreased? Okay, so remember, Le Chatelier's principle states that whenever an equilibrium system, okay, is disturbed, so what will the system do? The system will reattain new equilibrium by undergoing a net reaction, whether, okay, the system shifts its reaction to the left or to the right until equilibrium. So in this case, so what will the system do? Now, okay, So as you all have already learned this before in Boyle's law, remember Boyle's law? So Boyle's law states volume of gas, pressure of gas is inversely proportional with the volume of gas. Okay, so right now what happened was, if we compress the three gases, the volume of gas decreasing. And what will happen to the total pressure? So total pressure increases due to the decrease in the volume. So what happened was, in this case, when the volume is decreased, so gas pressure immediately increases. Okay, gas pressure immediately increases. Okay, so when this happens, okay, of course, the system will no longer be at equilibrium. Okay, I know you some of you might wondering why the system is not at equilibrium. Okay, class, if you look at Kp for this reaction, remember Kp for this system equals to partial pressure of PCl5 divided by partial pressure of PCl3 times partial pressure of chlorine. Remember Kp expression for this system. Okay, so right now what happened was, if we decrease the volume, the total pressure increase. And it is not just the total pressure, actually the individual partial pressures for each of the three gases also increases. Okay, why? Because class, so for example, let's say we take this PCl5 for example. So we know that partial pressure of PCl5 equals to moles of PCl5 times R times T over V. Remember, this is from ideal gas equation. Okay, same goes to partial pressure of PCl3 equals to moles of PCl3 times R times T over V. And also lastly, partial pressure of chlorine gas. Okay, moles of chlorine gas times R times T over V. So right now, if we look at the disturbance here, the volume is decreased. See, when the volume is decreasing, so what will happen? Now, let me change the color first. Okay, so now let's look at if the volume is decreasing, class. Decrease, decrease, decrease. Okay, so what will happen to the each of these partial pressures? So each of these partial pressures will increase, 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 increase. Okay, and of course, when all of these three partial pressures were increasing, so what will happen to the value of Q? So of course, QC is not equals to Kc, and that's why the system is not at equilibrium. Okay, so that's why the system is not at equilibrium. Okay, so right now, what will the system do? That is the question that we need to answer in this next part of this discussion. Okay, what will the system do right now? So in order, okay, to decrease the pressure, because right now you must be very clear that the disturbance is decreasing volume. So when the volume is decreased, pressure increase. So what will the system do? System needs to reduce this increased pressure. Okay, and then, okay, what will happen next? Okay, system will reduce the disturbance. So how the system will reduce this disturbance? So since right now volume decrease, so when volume decrease, pressure increases. So this is what the system is going to do. Okay, so this is what the system will do. Sorry, and this is what the system will do. The system will decrease this increased pressure. So how to do that? Okay, how to do that? Okay, the system can't change the volume because we have compressed the gases. So in order to reduce the pressure, okay, with the same volume, so what will the system do? System will reduce the number of gas molecules. Okay, why? Why the system needs to reduce the number of gas molecules? Okay, if you look at the ideal gas equation, P total equals to N total times R times T over V. Okay, so right now, volume can't be changed because volume is already decreasing. Okay, so temperature can't be changed. Of course, gas constant. So the only thing that the system can change in order to decrease decrease the pressure. So right now the system wants to decrease the pressure, wants to decrease this total pressure. So in order to decrease this total pressure, this is the only thing that the system can do. The system can decrease the total number of moles. Why? Okay, so maybe you might asking why? Because when the total moles decreasing, automatically total pressure decrease. So that's why in this case, in order to decrease the pressure, to decrease the increasing pressure, the system needs to produce less moles of gases. Okay, or we can say that the system will try to reduce the number of gases molecules and the number of gases molecules. Okay, so that's why earlier in this discussion for this case 1, remember when I showed to you the equation, immediately I've shown to you the moles of gas, the moles of reactants, gaseous reactants, and the moles of gaseous products. Okay, so actually this is we are going to use that here in this slide here. Okay, so right now from the previous slide just now, we know that on the left side of this equation there are 2 moles of gas. Okay, and on the right side or the product side there is only 1 mole of gas. So in this case, if the system wants to reduce the number of gaseous molecules, so which side should this system shift? Which side class to reduce the number of gas molecules? Yes, correct. Okay, so in this case, what will the system do? Okay, so the system undergoes a net reaction by proceeding to the right. Okay, to the right until QC equals to KC. Okay, why the system shifts to the right? The reason is because the right side has only 1 mole of gas. Okay, on the left side, there are 2 moles of gases. So in order to decrease the pressure, the system needs to decrease the number of moles. Remember, the number of gaseous molecules must be decreasing in order to decrease the total pressure. So in this case, that's why the system will shift to the right. Okay, the system will shift to the right until QC equals to KC. Okay, and what happened? And what happened finally once QC equals to KC? Okay, what will happen to the concentration of both of these gases, PC and Cl2, phosphorus trichloride gas and chlorine gas? So these two concentrations of these two gases, okay, shall be decreased. Okay, and what happened to PCl5 gas? Okay, the concentration of PCl5 increases. Okay, so this is what happened at new equilibrium. Okay, so this is at new equilibrium class. Okay, so this is the first case. This is the first case. All right, so now let's move on to the second case. I'm still using the same system, okay, but this time the disturbance is different. Okay, so now let's look at what is the disturbance in this case. Second case. Right, so time class. So what we did was we increased the volume. Remember the container just now? In case 1, just now, we compress the system. We compress the 3 gases. But in this case, what we did, okay, we increased volume. We increase the volume of this container by we pull up the piston. Okay, pull the piston up. Okay, and then what will happen? The volume, okay, increases. But inside this container, still, we have PCl3, okay, chlorine, and PCl5, and the 3 of these gases were at equilibrium. So now the disturbance is we increase the volume. Okay, so remember Boyle's law. So when volume increases, what will happen to the pressure? So pressure decreases. Okay, pressure decreases. Okay, so what happened when the volume is increased? Okay, the gas pressure immediately decreased due to the increasing volume. Okay, so this is the disturbance. Okay, and since the pressure drops, okay, the gas pressure decreasing, so that's why in this case QC is not equals to, okay, QC is not equal to KC, and that's why the system is no longer at equilibrium. Okay, and what will the system do? What will the system do? Okay, remember, so in this case, so what happened? We pull the piston up. Okay, so volume in this case increase. Okay, so now let's look at what will the system do. So in this case, okay, so the disturbance is increasing volume. So when the volume is increased just now, the pressure decrease. The pressure decrease. So what will the system do? The system will increase the pressure. Okay, so the system will increase the pressure. So how the system is going to do that? Okay, so means that the system must increase the number of gases molecules. So in this case, actually, it is the opposite of case 1 just now. Okay, so in this case, what will happen? Okay, the system, okay, will undergo a net reaction by proceeding to the left until QC equals to KC. Okay, right. Okay, maybe some of you still unclear why the system shift to the left. Why system shift to the left? Okay, remember, right now the disturbance is increasing volume. So when the volume is increased, so what happened to pressure? So pressure drops and the pressure decreased. So right now the system needs to increase the pressure. Right, so to increase the pressure, okay, so since pressure equals to moles of gas times R times T over V, so right now to increase the pressure, so that's why the system needs to increase the number of moles of gas, because the volume is constant, because the volume is already increased. Okay, so right now the system needs to increase the moles of gas. So that's why in this case the system will shift to the left. Why? Because on the left side of this equation there are 2 moles of gases. On the right side there is only 1 mole of gas. So that's why in order to increase the mole of gas, the system will produce more of PCl3, the system will produce more of Cl2. And that's why in this case, okay, once QC is equals to KC, the concentrations of both of these gases, PCl3 and Cl2, shall increase. And what will happen to PCl5? The concentration of PCl5 is decreased. So this is what happened at new equilibrium class. Okay, so that is how pressure affects equilibrium system. Okay, and now let's look at other example. So this time I'm using a different system. So we have sulfur dioxide, 2 moles of sulfur dioxide, 1 mole of oxygen gas, and 2 moles of sulfur trioxide. And these 3 gases were at equilibrium. And initially, these 3 gases were in a 10 liters container like this. And in this container, there is a piston here or plunger here. Okay, and originally class, so these are the moles of gas and the 3 gases in this 10 liters container. Okay, the volume is 10 liter, the initial volume. Okay, right. Okay, so let's say, so what we did, okay, we compress this gas from 10 liters to 1 liter. Okay, from 10 liters, we compress the gas to 1 liter. And see what will happen. Okay, remember, in this case, what is the disturbance? So the disturbance is decreasing volume. See, decreasing volume. And we have discussed this just now. Remember, in the first case, the first case for PCL3, PCL2, and PCL5 just now, for that system. Okay, so when the volume is decreased, so of course, the total pressure increases. And this is the disturbance. So when the total pressure increases, the system will decrease the pressure. Okay, the system will decrease the pressure. So how the system is going to do that? So the system will shift to the side with less mole of gases. Less mole of gases. Okay, for example, if we look at the equation here, so on the right side of this equation, okay, on the product side, there are 2 moles of gases, 2 moles of SO3. But on the left side, 2 moles of sulfur dioxide and 1 mole of oxygen. If we total up these two, we are going to get, on the left side, there are 3 moles of gases. So in order to decrease the pressure, what will the system do? The system will shift to the side with fewer moles of gas. So in this case, the system will shift to the right. Okay, the system will shift to the right. Okay, because on the right side there are 2 moles of gases, but on the left side there are 3 moles of gases. So the right side here has fewer moles of gas compared to the left side. So meaning that the system will undergo a net reaction by shifting the reaction to the right until QC equals to KC. And at new equilibrium, so let's see what happened at new equilibrium. So here, so we expect, what we expect here, okay, the concentration of SO3 shall increase, and both of these, SO2 and also oxygen, so these two shall decrease their concentrations. So this is what happened at new equilibrium. So now let's look at the moles, the moles. Now let's look at the data here. So class, see, remember, now let's look at SO3. See what happened to SO3. So initially the moles is 0.68, but at new equilibrium, see, its moles, okay, increases to 0.83 moles. See why? Because the system shifts to the right to produce more of SO3. And what happened to these two, SO2 and O2? Now let's look at initially, at original equilibrium, initial equilibrium, okay, the mole of SO2 is 0.32, but at new equilibrium, see, from 0.32 reduces to 0.17. There. Okay, why? Because at new equilibrium, less of SO2. Okay, the system needs to reduce this SO2, and not just SO2. The system also reduce the quantity or the amount of O2, oxygen gas, see, from 0.16. Okay, just now 0.32 to 0.17, and 0.16 reduced to 0.085 moles class. There. See? What happened to SO3? Sorry, what happened to SO2 and oxygen? Sulfur dioxide and oxygen gases. So both of the gases at new equilibrium, these two gases decreased. Okay, and what happened to sulfur trioxide, SO3? This SO3 gas at new equilibrium increased its quantity. Okay, increase its quantity, either in moles or if you want to calculate the concentration, yes, the concentration is also increased. Okay, and also the pressure. Okay, all right. Okay, so this is another example, how changing the pressure, okay, by changing the volume affects equilibrium position. Right, so as the conclusion for this lesson, so let's summarize what you have learned throughout this lesson class. Okay, remember, so if we change the pressure by increasing it, increase the pressure by, remember, how the pressure increases? By changing the volume. So if the pressure increases means volume decrease. Okay, so in this will happen to the equilibrium system. So the equilibrium shifts to the side with fewer moles of gas. Okay, fewer moles of gas. But if we decrease the pressure, if we decrease the pressure by increasing the volume, okay, by increase the volume, so this time the system will shift to the side with more moles of gas. Alright, so that's all for this lesson. So in the next lesson, we are going to look at how addition of inert gases affect the position of equilibrium system. Alright class, that's all for this lesson. I'll be seeing you again in the next lesson. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day, stay home, stay safe, bye-bye.